Hey guys, welcome back. I believe you guys are doing good. So let's continue with our learning. In today's practical, you're going to look at the OSPF virtual link. So you're going to understand what virtual link is and how you can be able to configure a virtual link in our OSPF network. So a virtual link is used in a situation where one area, non-backbone area, is not directly connected to our backbone area. So backbone area, like in this our topology, is area 0, but the area where we are going to establish a virtual link is between area 0 and area number 2. You see, area number 2 is connected to area number 1, but it's not directly connected to area number 0. But with OSPF requires that all the non-backbone areas should be connected to a backbone area to maintain the routing information into a router on a backbone. So that is the practical we are going to. So we just look at the networking requirement here. So in our networking requirement, this is the networking requirement here. The original OSPF, in the original OSPF network, is divided into area 0 and area 1. Due to limitations of the existing network, Area 2 needs to be planned and added to the entire OSPF network using switch B and as an ABR. Like this case is where initially maybe let's say the company was small, so we only configured area 0 and area 1, but now the employees have expanded, so and the company is now a big company. We want to increase our network. Now we'll add some areas to make sure we have got multiple area OSPF, so that we reduce the number of LSS being flooded in our network. So there we are going to add an area, but this area, it finds that we already configured a backbone area and area 1. Now we are going to link this area, new area, with area 1 through a virtual link. So that is the networking requirement. That is what they are trying to tell us in this our topology here. So that is the practical, and let's just do it. It's very short and we are going to do it very fast. So the first thing, as always, we configure VLANs, and also we assign the interface VLANs to IP addresses and allow the respective VLANs to pass. Like for this case, area 0, we are going to allow only VLAN 10. I'll do terminal monitor. We name that device, that is switch. The first device is switch C. So on switch C, we create a VLAN. So VLAN batch here is VLAN 10. Then we quit. You quit interface gig 0/0/1. This is going to be a port trunk port. So port link type trunk. Then tell port trunk to port trunk here will allow pass VLAN 10. After that, you quit and you enter the IP address for layer 3 communication. So interface VLAN if 10, or VLAN 10 is going to be .1. So IP address here will be 10.1.1.2 and this is /24. You save and you go to the next device. We are now on switch A. And do the terminal. So the name here, this is switch A. On switch A, we create a VLAN batch. So VLAN batch, you're going to create two VLANs, that is VLAN 10 and VLAN 20, because it is actually has an ABR. An ABR router is a router that stands between two areas, like here area 0 and area 1. So VLAN batch will be 10 and 20. Enter interface gig 0/0/1. Port link type is a trunk port, then port trunk. Tell it to allow pass VLAN 10. Then enter gig 2. Also being a trunk port, but this time it allows VLAN number 20. You quit and create the VLAN if IP interfaces. Interface VLAN if 10. IP address here will be 10.1.1.1 and this is /24. Then interface VLAN if 20. Interface VLAN if 20 has an IP address of 192.168.1.1/24. Save and move to the next device. We are now on switch B. TM. So switch B here, we give it the name to switch B. We create the VLANs. It has got 2 VLANs because it also acts as an ABR, area border gateway router. So we'll give it VLAN batch 2030. So interface gig 0/0/1. Port link type trunk. Then the trunk port allow pass VLAN 20 and a gig 2. Gig 2 is a trunk port allowing pass VLAN 30. Quit and create the VLAN if interfaces. Interface VLAN if 20. IP address here will be 192.168.1.2/24 and VLAN if 30. IP address here is 172.16.1.1/24. Save and go to the last device now. Our last device is router D. Ready? Give it the name to switch now. It is switch D, not router D. Switch D. Create the VLAN. Here we create only one VLAN, so VLAN batch, because this is an internal router. It acts as an internal router, so VLAN batch 30. So interface gig 1 0/0/1. Port link type is a trunk port, then port trunk to allow pass VLAN 30. Quit and create the VLAN if interface. So interface VLAN if 30. IP address is 172.16.1.2/24. Control Z and save. Having created the IP addresses to the VLAN if interfaces and also allowed the respective VLANs to pass, we are now going to configure now OSPF to enable communication between different subnets. So on router 1 here, the area OSPF, we are going to use now. Here we are going to use the loopback address of 10.0.x.x, where x here will now refer to the device number. Like here, switch C will act as the device number 3, switch A will act as device number 1, switch B will act as device number 2, and switch D will act as device number 4. So we just replace x with the device number. So we start with this our device here. So OSPF router ID will be 10.0.3.3. So area, we are on area 0. So area 0, we are going to advertise the network of 10.1.1.2. This is /32 best 0.0 wildcard mask for 0.0.0. Then on this switch here, so OSPF process ID is 1, then router ID here will be 10.0.1.1. Area is 0, and network of 10.1.1.1. Wildcard mask of 0.0.0.0. The next network will be Next network will be 192.168.1.1.1.1 wildcard mask of 0.0.0.0. So that you quit. Sorry guys, that network is on area number 1, not area 0. Display this. We're going to undo that our last network that was on area number 1. So Control C and undo. Area 0, display this, undo, display this again. It is gone. Now we are on area number 1. On area number 1, we will now paste that network. New display. So that network has been configured to area number 1. Then we go to switch B. On switch B here, OSPF process ID number 1 and route ID here will be 10.0.2.2 because it is switch B, it represented with the number 2, and area here will be area 1 and network of 192.168.1.1.1.2. I'll get a mask of 0.0.0.0. It's now exchanging the LSS and the state is now full. The neighbor state, the current state is full here. Then finally we configure for area 2 while on this switch. So area 2, the network will be network of 172.168.1.1. The wildcard mask of 0.0.0.0.0. Then we come to switch D. We also configure OSPF on switch D. OSPF route ID here is going to be 10.0.4.4. We are on area number 2. On area number 2, we configure the network of 172.16.1.1.2. Wildcard mask of 0.0.0.0. Okay, it has exchanged the LSS and the neighbor state is full. Now we go to switch A here and we display display OSPF routing. When we display OSPF routing, we only have the routing information for router number for area 0 and area 1. We don't have the routing information on area number 2. So meaning that there is where we're going to implement what is called now the virtual link. We're going to create the virtual link so that the areas on area number 2 can be advertised into our backbone area 0, so that switch A should be able to know about how to get to area number 2, and they should share their routing information. So the virtual link here, as you can see from the arrows here, it's going to be established between switch A and switch number switch B. So that is where we're going to create the virtual link. So enter OSPF area here. We're going to create area 1. On area 1, we are going to use now the loopback 0, the loopback that we created as our router IDs. We are going to use them to create the virtual link between switch A and switch B. So vlink peer, we give it the IP address of that the peer that is switch B. Its loopback address 0.2.2. Then we come to switch B. Quit. OSPF here. Area will be area. If we are on area number 1, we use area number 1 to create the virtual link. So then we create a virtual link, that is the vlink peer will be 10.0.1.1. Okay, you can see here the virtual link. We are being told here the virtual link neighbor address. Virtual link neighbor address is 10.1.1, 10.0.1.1. The neighbor event is hello received. Neighbor previous state was down. Neighbor current state is now in it, and the state is now full down here. After we created the virtual link, now the virtual state, you see how the virtual link establish the neighbor states, like from the negotiation done to exchange start, neighbor current state is in exchange, and until loading, then final stage will be now full state. So now let's go back to now our switch A here. We quit and we now display quit, display OSPF routing. When we display OSPF routing, now we can see it has learned a network of 172.168.1.0, and it is an intra area here, with the next hop being 192.168.1.2, that is on switch number B. So here we have got intra area R2 and inter area. We have got into area 1, into area, that is from area number 2. So that is how you implement OSPF virtual link. In case you have to increase your company's network, you just increase the area so that also the routing table don't become so huge, and you reduce the number of LSS flooded within our network. So I believe you've understand what a virtual link is and how you can configure a virtual link. So thank you for watching the video, and remember to share your comment in the comment section below. Also support our video by subscribing if you've not subscribed to our channel yet. So thank you, and let's meet in our next practical released every day.